Hey guys, my name is Sunny. For those who don't know me, I'm a researcher at Cosmos, Tendermint. I was also one of the co-founders of Blockchain at Berkeley about three or 4 years ago now. Go ahead and get started and talk a little bit about what is Cosmos. So the tagline I gave this talk was many chains, many tokens, one ecosystem, and hopefully I'll explain what that means. So before we start talking about blockchains, let's just talk a little bit about the evolution of human coordination. So I assert that the first stage was we had these ideas of villages and kingdoms where they were relatively isolated. You don't have much economic integration. You basically only really trade with your neighbors, and that's about it. And because of that, they just weren't able to scale very high. And so I assert that historically what we see is that economic growth comes from increased economic connectivity. So as you're able to trade with more people, you get more and more growth. And so I think the second stage of civilization was empires, where basically we realized that, okay, how do we get people in Greece to trade with people in Persia, right? It's how we do it is by having everything under a common set of laws and rules, where common ruler. So you have standards. You have if they don't want to trade, well you put a gun, you march your army on them and force them to trade with you. And so this is kind of what we did. And I'm sure I don't have to explain to you guys what the downfalls of empires are, the moral hazards and whatnot. So the third step was what we have today, which is nation states and city states. We kind of have a combination of them in the world, nation states, countries Germany, France. We have city states, countries like Singapore, Monaco, etc. And I actually think we're seeing a shift towards more and more city-states. We see this in for example, Catalonia trying to secede away from Spain, which I consider that sort of a city-state. And so essentially I think what the greatest innovation of humanity in the last 100 years was we realized how we can do economic integration without political integration. And so we did this through a multitude of technologies, including free trade zones, where we came to coordination, saying okay, in these areas free trade is the norm. We had containerization. We came to standards upon how to package goods and ship them. So everyone's following these same standards. We didn't need a government telling us to do it. Rather, we did it through voluntary organizations. And so institutions helped as well. Things like the UN. It's not quite a government, but it's a common forum where people can come to and discuss problems and whatnot, and hopefully try to resolve them. As well as the internet. I think internet has helped obviously a lot. Now it's it reduced transaction costs for doing business with anyone from anywhere over the globe. And I think hopefully blockchain will help push this as well, economic integration without political. But so yeah, these are sort of the technologies that helped create this more decentralized political environment that we see today, with high amounts of economic integration but low amounts of political integration, which is, I don't know, in my opinion, this is political. Obviously, it's going to be a political statement, but I'm somewhat of a localist, and I believe that coordination works at smaller numbers when people have more similarities, and the whole Dunbar's number and all that. So I think you can get better coordination through smaller political entities while still having the larger economic systems. So let's compare this to the evolution of blockchain development. Step one, generation one, came a bunch of independent blockchains. You had the Bitcoin. Bitcoin was the first blockchain. And then after that, you had many other blockchains that started coming along, each trying to do slightly different applications. Some of them were not doing different applications at all, right? Like Litecoin and stuff. They were just trying to play with the monetary policy a little bit. But then you also had some things like Namecoin trying to create a decentralized DNS system. You had Saya, who was trying to create a decentralized storage marketplace. And so you had all of these different blockchains, but they weren't really able to communicate with each other or anything. They were kind of all in their own isolated environments. There are also other issues with it. Back then, like, Bitcoin was the Bitcoin code base was the only blockchain code base that existed. And so if you wanted to make your own application, really what people used to do was like fork the Bitcoin code base and try to modify it. But like, Namecoin did this, for example, and it's just clearly a suboptimal solution. It's very poorly designed because it's a fork of the Bitcoin code base. And the Bitcoin code base is like, wasn't designed for that. It was designed to do payments and nothing else. So we'll get into that a bit. But then along came generation 2, the empires. These Ethereum basically created what I consider the first empire, which basically said, okay, here is like one monolithic stack, and build your applications on top of me, and I will provide you great amounts of economic connectivity, and you can have like the 0x project. I can use my Maker DAI to trade to gain leverage on like and then I can like use that in a 0x or something. So you get high amounts of economic integration, this whole like DeFi movement that's been going on in Ethereum. But you also get a lot of cons. You have like very little, any individual application has very little control over governance. You kind of like, if you, let's say your system has some issue with it and you need governance to solve it, you somehow need to convince the entire Ethereum community to bail you out rather than just like your own personal community. So you lose out on some, your community loses out on some level of sovereignty. You also have to, to use Ethereum, you have to pay your fees in Ether. This is essentially a tax. It's like no different than the tax that empires charge on like, their constituents, right? And so essentially, the more people they have using Ethereum, it boosts the price of the Ether token. Well, maybe if you had your own blockchain, you don't want to do that. You can use your own your own token to pay fees. So I propose that the solution is this: Generation 3, where we have many application-specific blockchains that are all interoperating with each other. So this is a Cosmos hub chain. This is Namecoin, Saya, Augur, Bitcoin, Ethereum. I still think smart contracting systems will stick around, and I think they're useful. But I'll get into a bit later of where they're useful. But we're not going to have Turing complete VMs here. We're not like the Augur contract is not going to be a smart contract written on the EVM. It's going to be like something that's written into the core code base of that blockchain. So kind of like how Bitcoin, its code base isn't written on the EVM or some VM. It's just in the client code base. And this has a lot of efficiencies and whatnot, which we'll get into. And so that's what I imagine that most of these blockchains will end up looking like. You'll still have some of those Turing complete VMs, and we need a way for them to interact with each other. We need these links between them where they can send data between each other, send tokens, send assets, like build a common economic connection. And so that's nice. That sounds good from like, but I don't want to make just an appeal to analogy here, right? Like, I think that this like generation 1, 2, 3 of the blockchain ecosystem clearly, maps very well to the of human coordination, but that's like not a strong argument. So let's talk about why. So what I'll do for this presentation is explain why we want this kind of design, what tools my company Tendermint is creating to build this, and so we'll start by talking a little bit about like why do we want a generation 3? What was wrong with generation 1, and what was wrong with generation 2? So generation 1. The benefits here are the sovereignty aspect. Like, the Saya community has control over the Saya blockchain. When they realized that people were like, there were ASIC manufacturers who were about to like, gain a controlling share of the Saya blockchain network, they hard forked their hashing algorithm, right? This is something that they could only do because it was a small, close-knit community. You have way more efficient state machines. I claim that the Bitcoin state machine is way more efficient than the Ethereum, the EVM, because it's it's just simpler. It's adapts. You're running compiled code, not interpreted, and you get a high amount of customizability, right? Like the other thing with Ethereum is like in the Empire model is like they force things upon you. So for example, like you can't choose what cryptography you want to use because Ethereum only has certain precompiles that they chose what precompiles to use, and you can't say, oh, I don't want to use SHA-3. I would rather use like a different hashing algorithm. You can't do that, and so you lose out on a lot of customizability when you're living in someone else's empire. And so that's what, these are the benefits that Generation 1 gave us. Generation 2, on the other hand, gave us, all that interoperability I've been talking about. It made it easier to develop. So like I said, if anyone's tried playing with the Bitcoin code, it's like this spaghetti code, C++, monolithic, very messy. It's very hard to understand. And it's because of that, it's very hard for people to fork it and make complex applications with it. So Ethereum, made it way simpler. Solidity is not fun to write, but it's way better than trying to modify the Bitcoin code base. And Solidity is not, it's getting better and better over time. So Generation 2, it made it way easier to develop. And there was this whole one-click deploy thing where I write my code as a developer, but I just press a button and it deploys it and it's live. I don't have to go out and find miners to mine my chain and whatnot. So yeah, so the goal here would be we want this Generation 3 to somehow combine the attributes of both Generation 1 and 2. Can we get the best of both worlds here? And that's cool, but let's go even further. How much can we do even better than just that? What are some, if we're going ahead and building another generation, what else can we add to this system? So, when looking at designing distributed systems, one of the best places to always look for inspiration is the largest distributed system in the world, which is the internet. And the internet, its goal was to connect multiple separate networks of servers into a single network of networks. That's kind of what I'm proposing our solution is, Cosmos, the internet of blockchains. The ability to scale in terms of throughput and geography, and the ability to tolerate and recover from failures. Well, if we look at our goals for the internet of blockchains, it's actually pretty similar, right? We wanted to be able to scale in number of users and throughput and geography. We wanted to tolerate and recover from failures. And so, let's go ahead and add those two to our list of desires that we want, scalability and fault tolerance. And then I'm going to add a third one that I personally, care a lot about, which is, this is the energy consumption of proof of work over the last year. Luckily, it's gone down a little bit because the price of Bitcoin has gone down. But at its peak, it was doing 75 terawatt hours per year. Everyone always gives the analogy of, oh, that's as much as this country. I don't know what it's actually similar to, but I heard something like Denmark or something was at the peak was what it was using as much electricity as. So yeah, this isn't cool. I don't want, I want to care. I want to let's also worry about making this sustainable. So these are the 9 goals that we have in the Generation 3 of blockchains. So, and there's a 10th goal that Cosmos, isn't our focus, which is privacy. And so the whole Generation 1, 2, 3 is always a little bit misleading because where does Zcash fall on that it's not a linear timeline. It's really a tree of development, or even a DAG. Things are borrowing stuff from each other. But privacy is a very important 10th thing that we need to work on. But quite honestly, the Cosmos team, that's not our specialty, and so we don't really focus on that ourselves. Instead, we just give a lot of money to people who do that. So we fund Dan Bonnet's lab at Stanford, as well as Alessandro Chiesa's zero knowledge proof research here at Berkeley. So that's not our focus, but that's definitely something.
What's the difference between the Dan Bonnet and also the Berkeley research, in your opinion?
Oh, well, so Dan Bonnet, so Chiesa, he's basically focused completely on zero knowledge proofs. That's his focus. He was one of the co-authors of the ZK Snarks paper. He's one of the co-founders of Starkware. And he's currently working on a new construction of zero-knowledge proofs called Aurora. So Dan, on the other hand, he's more I don't think he actually does much in zero-knowledge field at all. He's just focused more on BLS signatures. He's been doing a lot of work on aggregators lately. So he's more I'd consider traditional cryptography and making things more efficient, while Chiesa is more on the zero knowledge proof side of things. Okay. And so on the privacy side, so one of Dan Bonnet's grad students, Benedict, he helped create bulletproofs, which is also a zero knowledge construction. So they do dabble in it a little bit as well. Yeah. Also, sorry, I should have mentioned this earlier. Feel free to butt in with any questions at any point. Thank you for that.
Yeah.
So yeah, back to this. 9 goals. All right. So here's what we want to create. How are we going to do this? These are the tools that Tendermint. By the way, it's going to be a bit confusing because Tendermint is the name of our company, but it's also the name of a bunch of our tools, and so it will be a little bit confusing, but gotta bear with it. So these are the 1, 2, 3, 4, 11 tools that we're building, and that are going to achieve the goals that we want for this Generation 3 blockchain ecosystem. From here on out, I'm just going to call this Generation 3 thing Cosmos. So Cosmos is not the name of a single blockchain. It's not the name of, Cosmos is just the name of this vision of how do we create a Generation 3 ecosystem of application-specific chains that are all talking to each other somehow. So these are the tools that we're going to use. Tendermint, Cosmos SDK, and IBC are kind of like what we call our 3 flagships. And then, some of the, peripheral stuff that go along with, helping us achieve those 9 goals that we want. Yeah.
Are any of those like 100% production ready?
Yeah. So the one that's the most production ready is Tendermint Core, which is the next thing I'll be going into. But it's, it's been around. I'll just actually go into it. I'll jump into it. So we'll start off with Tendermint because that's the first thing that we created. Tendermint was created by Jay Kwan back in 2014. He was just really, he wanted to make an exchange, and he was worried about the finality properties of proof of work. So he started reading into BFT research, and he read PBFT, and he was like, oh, I think I can make this better. So he created a consensus protocol called Tendermint. And so Tendermint that's also why it's the name of the company. So they spent, Jay and Ethan Buckman, who's the CTO, they spent about 2 or 3 years developing Tendermint alone. And then we started working on this Cosmos vision about 2 years ago when we were like, all right, we have a BFT consensus engine. What can we do with this now? And then that's kind of when we started thinking of okay, this is this whole Cosmos vision that we're building. So Tendermint, it'll be a little, so Tendermint is also, like I said, it's an overloaded term. It's the company, but it also refers to the consensus protocol, this abstract notion of the protocol, and which I'll call Tendermint BFT. And then this Tendermint Core, which is our actual implementation in, it's a software implementation. So with Tendermint BFT, it's basically this 2-round commit system. I don't want to go too much into the technicals of Tendermint. In each of these sections, I'll have a list of further reading you can do if you want to learn more about any of these topics. So essentially, this is a great, obviously you can't read it right now, but this is a great, one poster. We need to print it out and have it in our office. I don't know why we don't yet, but this is probably the best, quick explanation of Tendermint BFT that I've seen. I'll have a link to it. So yeah, what is Tendermint BFT? It's a simplified and improved BFT. So what this means is, I can give a brief summary. What happens in PBFT is you have a BFT consensus protocol that's going, and you have one leader who is proposing values, and everyone else is committing. And it works very well in this situation. But the leader stays the same. If the leader goes down, PBFT switches to a different mechanism for leader re-election. And this leader re-election mechanism is very complex and whatnot. And so a lot of thought has gone into improving the leader re-election. So if you guys know Thunder, they have a mechanism where they fall back to a proof of work blockchain to do the leader re-election. I think that's actually very silly. What Tendermint does instead is basically what Jay's innovation here was he figured out how to do it all in one round, or in one mechanism. So you can do the leader re-election at the same time as you're doing consensus on values. And so what this does is, it allows you to not have this. It simplifies the protocol significantly, and it also allows you to change the leader every single block. So you can imagine that PBFT is not good for a public blockchain because that you're designating one person as the proposer every single time, and that's a huge censorship concern, right? But with Tendermint, you can change the proposer every single block, and this it's a censorship resistance mechanism because now you don't have one proposer who can choose what transactions go in or not. If one proposer is censoring you, it's fine. Hopefully the next proposer will not be. And it also was very well designed for working over a gossip network, where the problem in PBFT is when there's Byzantine faults, like malicious faults, to show evidence of it, there's a lot of back and forth required. So if we you faulted and I wanted to share information from you, there's a lot of back and forth communication, and it kind of assumes that the two people have a direct connection to each other. Tendermint, the evidence is very compact, and that makes it very efficient for propagating over a gossip network, which is what blockchain networks usually are. And so it's also very well designed for use in public gossip networks over the public internet, while PBFT was only really ever tested in private permission settings. So Tendermint, we are heavily consistency prioritizing or safety favoring. So Tendermint, what it will do is if there is it is safe in asynchrony. So what that means is, let's say half the nodes cannot talk to the other. The transatlantic cable was cut or something, right? The entire blockchain will halt. No more blocks will come until we figure out how to resolve the situation. A liveness favoring blockchain, on the other hand, such as any proof of work chain, it will instead go split brain and start creating two forks that will not be able to resolve. And so I think the safety favoring it's very important from to me, blockchains and consensus protocol were about coming to consensus. Why would you want something that is inferior to coming to consensus? I think safety favoring systems are superior to liveness, but and so we have provable liveness and partial synchrony. So unlike Bitcoin, where if the synchrony time accidentally goes, so let's take Ethereum, right? It has block times of 15 seconds. If the network delay exceeds 15 seconds, the blockchain will never be able to resolve. It'll just remain in a perpetual fork where it will never come to consensus. In Tendermint, as it doesn't matter how long the delay is, as long as it resolves at some point, it will continue to make progress. So if let's say the block time suddenly, the network propagation time suddenly jumps to 30 seconds, it's fine. The system still works. It'll just be making blocks every 30 seconds instead of 1 second. Yeah, I talked about the rotating proposer. It has a safety threshold of 1/3 of the validator power. So as long as less than 1/3 of the validators are not malicious, it will never fork. And as long as less than 2/3 of the validators are not malicious, we will always be able to attribute who was malicious and be able to punish them somehow. And then finally, we have Tendermint 2.0 in progress. That's how we can make it even more scalable. Things like BLS aggregation for signatures, pipelining. So these are all if you're interested in that kind of stuff, you can come talk to me afterwards. And so why does Tendermint BFT help from a scalability perspective? It comes down to that idea of safety and asynchrony, and rather liveness and partial synchrony. The problem with Nakamoto consensus is if your propagation and mining time exceeds your block time, the system will go split brain, like I talked about. You'll have two forks that will never be able to resolve. On Tendermint, however, so that's what happened here. What happened here is the block. This is step one. The time increased. Now the system went split brain. In Tendermint, on the other hand, let's say the propagation time went increased suddenly. It's okay. The liveness and partial synchrony aspect of Tendermint will just increase the block time and make it safe. And so what this allows is it allows you to push the block time as low as possible. So in Bitcoin, the reason the block time is so high is in 10 minutes is because they're very paranoid that they don't want to ever get into this situation. So they think 10 minutes is a long enough time. Same thing with Ethereum. You can't really push it lower than 15 seconds. And already that 15 seconds I think is a little bit too low. We're having too many orphan blocks right now. That's why in Tendermint you can push the block time, have the default be 1 second, and it's fine because if it doesn't work in 1 second, it'll just happen whenever it needs to. And so you can have way more blocks happening, way more transactions happening. The safety property of Tendermint allows you to push the system to its limits, which you cannot do in Nakamoto consensus.
So
Yes.
how real of a concern is that? Like, will that ever happen in Bitcoin, or is it? Are you
Not in
saying-
Bitcoin because 10 minutes is insanely high, but in Ethereum, I could totally see it happen. 15 seconds and sudden internet network delays, like pushing it beyond 15 seconds, I think is a very reasonable system, especially when you're starting to like run over. Let's say you're trying to run your blockchain over Tor or something, right? Where like the network delays are very high and unpredictable. Yeah. So Tendermint. All right, it helps us with two of these concerns we were caring about, which is the scalability, like I talked about, and the fault tolerance. And if you want to learn more about Tendermint, we have a formal specification written by Zarko, Jay, and Ethan. A lot of people didn't like Tendermint for a while, like a lot of academics, because Tendermint has a very engineering focus rather than academia, and so we just we wrote like a small spec, and just started implementing it without doing the form. We had heuristical proofs, and so that's why a lot of people, academics, were like, oh, it's not real until you have a proper paper. So finally this year, last year, October or so, we finally put out a proper paper with formal proofs of safety and liveness, and so you can go ahead and read that. That link, that cool poster thing, that's that link. And Christine wrote a blog post a few months ago comparing Casper to Tendermint. And so, one of the main things is Casper still seems to be liveness favoring for what reason I cannot imagine. So, Tendermint Core. This is our actual implementation of Tendermint. So it's written in Go. There is some very early progress in rewriting it in Rust right now. But it is the first production-grade BFT consensus engine. A lot of people thought that BFT doesn't scale because almost all of the implementations were written by grad students for their thesis or something, and so they wrote it in Python, single-threaded. That's not how you build a production system. If you want to build a production system, you need to have concurrency, multi-threaded systems, and you also have to writing a Tendermint looks so simple in this nice little diagram, but when you actually start getting to writing an implementation, it's you have to start worrying about you think you're on round 3, but you're suddenly getting blocks from round 5, and you're like, what's going on? Are these malicious blocks, or are these am I just delayed from the rest of the network and everyone else is on round 5, I'm on round 3? You have a lot of caching, and building the production implementation is much more complicated than just a small prototype. Yeah.
What is Rust going to give you that Go doesn't?
Just slightly better performance. I'm not a Rust developer, so everyone else seems to be going crazy over it. So Ethan Buckman, who's the CTO, he's the one who's really been pushing the rewrite in Rust. So I think he's just working on it on his own right now as a little side project. But I think it's just a performance benefits. Yeah. And so yeah, Tendermint Core, first production-grade BFT consensus engine. I think the second production-grade BFT consensus engine we're starting to see is the Honey Badger implementation by the POA network team. So I have an eye on their implementation. It's pretty cool. And so what Tendermint does is it handles all the P2P and consensus logic for you, which I'll get into in a second. And here's another view of how Tendermint works. Yeah, so scalability. This benchmark was from 3 or 4 years ago, so this is very clearly outdated. And this 14,000 number sounds high, but it's very misleading because this is Tendermint running without a state machine. We're just coming to consensus on bytes, but not actually processing those bytes in any way. So in a blockchain, really, you're a lot of the limit is actually in the state machine, not in the consensus protocol. So as soon as you slap an EVM on top of Tendermint, it quickly jumps from 14,000 to 200 transactions per second. But that's still way better than Ethereum proof of work's 15 transactions per second. So there is you do get some scalability benefit. It's not as it's not the magic bullet, because really what you have in scalability is there's two types of scalability. There's what's called vertical scalability and horizontal scalability. Vertical scalability is how much you can scale a singular blockchain. So scaling, it's kind of like scaling, getting a beefier and beefier server. While horizontal scalability is you have you scale out, like you buy more servers that are, or you use some sort of parallelism. That's what like horizontal scalability is. And so Tendermint Core gives you a decent amount of vertical scalability, but it's not the magic bullet, which is why we need the rest of Cosmos for the horizontal scalability. So the other thing, what Tendermint does is a blockchain essentially has 3 layers to it. There's a networking layer, which handles peer-to-peer, gossip, etc., transaction propagation. There's a consensus layer, which does like the actual BFT consensus engine. And then there's an application layer, or a consensus layer could be like the proof of work. And then there's the application layer, which is the state machine of a blockchain. So in Bitcoin, it's their UTXO processing system. In Ethereum, it's the EVM is the application layer. What Tendermint does is it creates a standard software stack that handles these bottom 2 layers for you, and then you can write your application layer in any language you want, and it talks over a socket protocol called ABCI. And so it's similar to like you could have like different services running that talk to like an Apache web server. Same thing goes here. You have your state machine written in any language you want, talking to Tendermint Core. And so you can take the EVM, run it on this called Ethermint. Someone took the chain.com VM and ran it on Tendermint. They called it Chainmint. And we have implementations of we have example applications for running on Tendermint Core in like every language from like practical to OCaml. And another cool thing what Tendermint does is it allows you to define your own validator set however you want. So you can use Tendermint in a proof of authority setting, in a permission setting, or you could use it in a public proof of stake setting. You could even use it in a proof of work setting if you wanted to. Not in Nakamoto consensus proof of work, but rather people are doing hashing, submitting hashes to the chain, getting voting power, and then are able to use that voting power to become validators in the system. I haven't seen anyone implement this yet, but I'll probably go ahead and do it at some point if I don't see anyone else doing it for a little while. I want to show a proof of work BFT system, so that'd be really cool. And one of the benefits of this, like being able to define your own validator set, which is what Tendermint Core allows you to do, is it enables a level of sovereignty. And so, if anyone knows what this flag is, it's the flag of a country called Liberland. It's like this little made-up country in between Serbia and Croatia, caused by an interesting, weird geographic quirk. And so, I've been helping their team out. Just for me, it's just a little sandbox for different blockchain like proof of concepts. So if I want to create like a voting system or something, I'd go test it in Liberland and then like go to a real country and be like, hey, look at my little sandbox. It worked there. Do you want to like try it in like Zug or something? So that's what I've been helping them out with that project a little bit. And so one of the things is that I believe that you can have higher security than pure economic incentives alone. This kind of goes back to my whole belief in like localism, where if you have like some level of community incentives beyond just pure economic, you can achieve higher like coordination and security. So if like all the validators of Liberland were Liberland citizens, right? And that was part of the mechanism of like becoming a validator, that could, they have social and political incentives beyond just pure economic, and they're less likely to try to attack the system than if they were just doing it out of a pure profit motive. And so there is this but it could still be proof of stake, but with other requirements, right? So having to have the Liberland asset citizenship, it's like an asset, and so it's like marked on your UPort ID. So that could be a requirement. So I think there's this like interesting continuum between private and public blockchains. It's not just this like binary thing. And so there's a lot of room to explore there. And I do think sovereignty can help you with security. So, right, Tendermint Core, these are some of the benefits I gave. We got that sovereignty I just talked about. You have the customizability. You can write your state machine in any language you want. You can write any state machine you want. You can take an existing state machine and run it on top of Tendermint, like we saw with like the EVM or the chain.com VM. It helps with the scalability, like the vertical scalability we talked about, and it helps with that one-click deploy system where you no longer have to go out. Well, you still have to go out and find your validator set, but it helps in the situation where like you don't have to write a consensus protocol or peer-to-peer logic. Like most developers, they want to write their application logic and not go and write a consensus and peer-to-peer by themselves. And so it's nice that Tendermint just wraps this up and handles it for you. And so if you want to learn more about Tendermint Core, there's the documentation. There's some performance testing results that are way more recent. So that graph I did was from like 3 or 4 years ago. These results, BigChainDB just did some performance testing about 3 or 4 months ago. And so they have way more up-to-date performance numbers. And then Ethan Buckman's master's thesis, which kind of, it's also a good resource for just Tendermint BFT as well as some of the design of Tendermint Core. All right. So, like I said, yes.
So about BigChainDB, they announced that they were going to integrate Tendermint last year, and they said that as soon as it's stable, that they'll launch it and announce it. And what's been kind of the delay in
I'm not sure what the status of BigChainDB is as a project. From what I understand, last thing I heard was like, they gave created a BigChainDB Foundation, gave that project to BigChainDB, and now they're focusing full time on Ocean Protocol. And I'm not sure who's actually developing BigChainDB right now. I'm not too up to date with the actual internals of their project right now. Sorry. And by the way, a number of people are using Tendermint Core already who maybe aren't using any of the rest of our stack, not using our Cosmos SDK or anything. So like we have like a FX exchange that does over $1 billion per day. They're using Tendermint Core internally. The national Thailand is using Tendermint right now for their national ID program. I heard rumors that PBOC, the People's Bank of China, is using Tendermint Core right now. So yeah, there's a number of people who are using Tendermint already and in production systems. Yeah, and so any other questions about Tendermint BFT or Tendermint Core?
Yeah, one more. Yeah. So, if you go to GitHub, it says alpha, don't use, and every time it's been in the past that every time there's an update, the file format changes and it's not backwards compatible. Is that still the case? Pretty much every update will make you restart your...
Yeah, right now, basically right now, even Tendermint is going under rapid iteration. Largely not on the BFT consensus side. Like the consensus logic is pretty standard. Like that is done, and like we're not playing too much with that. What we're playing with more is like a lot of the stuff around like ABCI and stuff, like some of this adding fields to that protocol, that socket spec and whatnot. So yes, right now Tendermint Core is pretty solid from a BFT standpoint, but just from the tooling around it, it's still going under rapid iteration. And so if you are using Tendermint Core, we do highly, right now, until it reaches some level of stability, we do recommend having some sort of direct lines of communication with us. Like we'd love to add you to our partner Slack or whatnot to coordinate there.
Yeah, one of my experience last year is okay, well, you got one version and you upgrade to another version and all of a sudden there's new requirements in config files. So
yeah.
So I don't know, I'm kind of hoping for a time where it's stable and you can say, okay, it's this version and the next version is going to not require you to change your infrastructure.
Right. We're going to start shifting into more versioning, better versioning, where we'll continue to support older versions and obviously upgrade them with bug fixes and stuff. Right now we've kind of been only having one development pipeline where bug fixes are going in the same spot as features and whatnot. And so we do definitely have to improve on that process and make it easier for our end users, which is you guys. Yeah. Right. Okay. So like I said, you can use Tendermint Core with any mechanism of choosing your validator set, and that's decided by your state machine. Your state machine basically tells Tendermint Core, here is the validator set. And you can use it with permission system, but we personally propose is using it with what we call bonded proof of stake. And why proof of stake? This is like a tweet thing I did from like 2 years ago now, 2017. But like, there's a lot of benefits, which is like, the environmental, the scalability, which is actually not correct because proof of stake itself isn't what's giving you scalability. It's the BFT, Tendermint BFT that's giving you scalability. But people often same thing with proof of work. People often mix up Nakamoto consensus, the consensus protocol, with the Sybil resistance mechanism, and they're really pretty distinct. Same thing with here. So scalability, not really, but it could possibly help with decentralization, where ASICs continuously just keep getting more and more centralized. It helps you with dishonest resistance. And so some basics, you use bonded tokens as the resource limiter for determining voting power. So you take some of your tokens, and one of the chains that we're building called the Cosmos Hub, the token is called an atom. So you go ahead and take your atoms and you put it in a bond, and whatever percentage of the bonds you have were yours, that's how much voting power you get. And it eliminates the wasteful energy consumption of proof of work. Instead of using energy as the resource limiter, you use locked capital. You build, and in my opinion, Dan Robinson made this click for me, where in proof of work, when you burn electricity, you are burning society's resources. When in proof of stake, when you lock up capital, you're actually just redistributing society's resources because everyone else becomes slightly richer. And so it's not a waste of society's resources, which really bugs me. It's a public permissionless system. I maintain that it is just as, a lot of people will say, oh, there's more censorship concerns in proof of stake than in proof of work. We can have this discussion afterwards, but I maintain it is just as censorship resistant as proof of work for any practical scenario. And so we can have that discussion later. Yeah.
So 2 questions. The first is around distribution. It seems as though proof of work, even though you may dislike the burning of resources, it is a very effective and fair distribution method to get coins out into the market. And the second question is around how, what is the incentive for people to actually stake outside of, why do people lock up their capital? How is Cosmos going to compete with, other reasons to allocate your capital elsewhere? Is it going to have a return? All those things.
I will answer that question in 2 slides. And then we solve this nothing at stake problem with slashing and unbonding period. So, Tendermint Core, it tells the state machine, oh, I found these malicious validators, do what you want with them. And so our bonded proof of stake mechanism, it burns their coins, and there's other things you can do with them. You could put them on a bulletin board, and everyone can publicly shame them. But we focus on economic incentives of burning their coins. And we have a mechanism for delegation where the process of running a competent validator is not easy, despite what a lot of Ethereum community would like to think. I run a validator called Sika, and it requires running a hyper secure, always online hotkey. And if anyone can hack that validator, they can burn all your money. And so that's not okay. That's not accessible. Your grandma is not going to be running a validator, right? And so, but this delegation mechanism allows anyone who has coins to still, delegate it to a validator and still participate in the staking process. Choose which validators to go to. They have skin in the game, so if their validator misbehaves, they get slashed as well. So they really have to be very careful with who they delegate their coins to. We have automatic reward distribution. So unlike for example Tezos, a lot of their bakers have just been running away with their delegators' funds. Instead, we have an efficient mechanism for making sure the rewards get distributed properly to the delegators, and so there's no risk of the validators becoming malicious. The validators can't screw over the delegators without also screwing over themselves. That's kind of one of the goals there. And we also solve a lot of the stickiness issues with proof of stake, with features such as instant redelegation and something called validator commitments. I gave a talk at CSC. I'll have a link to that talk. You can go watch that if you want to learn more about proof of stake, about all of these cool features that we've created. And so to answer that question, the multi-token model, our claim is that we are not trying to make money here. The staking token should actually be only a staking token and nothing else. In fact, we make it very inflationary in order to punish someone who is not staking. Our goal is to have the majority of atoms be staked. Like we're talking about like over 80% probably. Money in our system is going to be other stuff, maybe Bitcoin or stablecoins, whatever. And the incentive to stake is you earn the fees that other people are using. And so our system allows you to pay fees in any token. So you don't have to, like I said, we don't like these empires who are charging Ether for fees, right? We want a system where if you have Bitcoin and you want to pay your fees in Bitcoin, you can do that. If you have ETH and you want to pay your fees in ETH, you can do that. If you have DAI and you want to pay your fees in DAI, you can do that. So we have an entire mechanism designed to allow this. And so as a validator, your benefit of staking is that you earn the fees that people are paying in monetary assets like BTC and ETH and DAI and Dogecoin. And so it's very similar, and this like staking token model is very similar to the ASIC security model, where like, you know, it's why ASICs are more secure than GPU systems, because if you have the majority of staking tokens already staked, it's very hard for an attacker to suddenly buy up a large amount of staking tokens on the open market. And yeah, like I said, it massively improves the user experience, and we get away from this like empire-like mindset where we have single fee tokens. Yeah.
You were saying this before to me, but how come you don't think fees should be paid in the token that uses stake?
Because if the staking token has too much utility outside of staking, it's going to be too liquid on the open market, making it very easy for an attacker to suddenly buy up a large amount of the staking tokens. It's an argument with ASICs as well, right? Like you can imagine that almost every ASIC every SHA-256 ASIC in existence right now is actively mining Bitcoin, right? Or Bitcoin Cash, I guess. But and that's why, like, you know, minority hash power chains are not secure, because it's very easy to suddenly bring in a whole bunch of new hash power into a chain that like doesn't have it. But if you in Bitcoin, the ASICs are helping secure it, because it's almost impossible for any individual to go buy like 51% of the ASICs in existence, right? And the only way for them to do it is to manufacture those ASICs, which isn't really feasible in a non-detectable way.
You know, you also mentioned like there's 80% is proof of stake.
That was a number I made up, but I'm talking about something like a high number.
High number, sure. Yeah. And then is that a 20% proof of work?
No, sorry. What I meant was 80% of the staking token. So let's say there's a billion atoms in existence. Yeah. We want 800 million of them to be staked. That's what I meant by 80%. Maybe there's 200 million that's open because people are actively using them for trading or whatever they're doing with it, right? I don't know.
Well, I guess my question is, I mean, you guys are token, right? You trade, right?
Yeah. But the idea is it's going to be hyperinflationary. So if you don't, the longer you have your token not being actively staked, you're going to be getting like inflated away very quickly. In fact, we didn't want to do inflation. If we could have, we would have rather implemented it as a demurrage, where like if your stake token is not, kind of like an ASIC, right? If you're not using your ASIC, it's just like degrading in value because it's not.
So my question is, I mean, you know, for mining purpose, I mean, do you set up in such a way as, I mean, it's a combination of proof of work or proof of stake?
It's only proof of stake. There's no proof of work at all in one of the in this bonded proof of stake mechanism we're building. Yeah. There's no proof of work. Now, like I said, that's not to say you can't use proof of work in your own chain and connect it to Cosmos, right? You can completely do that. Okay. This just has to do with that, like one of the goals that I really cared about, sustainability, and we wanted to build a tool that if your chain cares about this, use proof of stake. If you want to go use proof of work, you can do that, and it's completely permissionless. The point of Cosmos is to be an open system where it doesn't discriminate on this basis, on like the basis of that.
Sure, I think proof of work is too much consumption of power.
Yeah, and so basically what we've been spending a lot of time on is making sure that like trying our best to mimic the security properties of proof of work in proof of stake, and like especially like the centralization concerns. I think every proof of stake mechanism that's been proposed so far is going to be way too centralized until we've added these things like instant redelegation and whatnot.
So you're talking about losing to inflation, but you're also saying it's not inflationary. I'm trying to reconcile those.
No, no, this Atom token is hyperinflationary.
Right, so does that mean that new tokens are injected into the system?
Yes, and it's going to the state
Okay.
holder. It's, yeah, so if you're staked, it's going towards this. You get a cut of those new tokens. What I would have liked to do is do demurrage, where it's not there's no inflation, but rather tokens that are not staked are just decaying in value. This would have been really nice. I think it's simplistically like it's it's mentally simpler to think about, and it would have also been nice from a tax perspective because then it's not income, but if you're staked, it's rather capital gains. That would have been nice, but it's just very hard to implement this from a technical standpoint and from a UX standpoint.
So you're basically saying people who have atoms stake, they keep getting more and more atoms.
Yeah, but really the
so
goal.
when exchanges, they're dropping in value.
Yes, that's the goal here, and the goal is to like allow. The idea is that people who aren't staked are having a smaller and smaller percentage of the total supply of atoms. And the total supply of atoms, the valuation can be like thought of as like a discounted cash flow on like future fees coming into the chain. Yeah.
How does that prevent centralization? Because it seems like if I have 30% staked and it's hyperinflating if it's not staked because I'm getting all the new tokens, then the rich get richer kind of a scenario.
Yes, but like I said, it's not going to be that there's no liquid atoms, right? Like, it's not possible to imagine that like 100% of atoms are staked. And we actually designed our inflationary mechanism so that the less atoms that are staked, the more hyperinflationary it becomes to encourage more to stake. And then as it reaches higher numbers, like 80%, the inflation amount like decreases. So that way we still have some amount of liquidity in the open market. Yeah.
So does the inflation come in the form of the transaction fee values changing over time? Or are you, because you can really, like in the market, in an open market scenario, right, you can have any crooks you want, but that doesn't mean that the market's going to follow that. So how does that?
Are you saying does the inflation account for changes in price of
So if
atoms?
you just inject more
Yeah.
coins, right, but the value of the transaction to stake, right, into something remains the same,
Yeah.
you just added more currency to the system, right?
We can't force rationality upon our users, but like the idea is that like in theory, as we inflate the system, each individual token should become less valuable, but the overall market cap of the entire atoms shouldn't be changing just because we're inflating it.
What are those ranges of inflation? Is it like double in 7 years, or like what's that?
Yeah. So no. So I'll say this, and I mentioned this in my actual proof of stake talk, which is this link right here. But like all of these constants that we're using are just made up right now. Like in my proof of stake talk, one of my constants I used like e over pi for one of my constants just to show the absurdity of some of these constants, where these are, and they're just as absurd as like any of the constants that like even Bitcoin created, right? Like 21 million, where did that number come from? Halving every 2 years, where did that number come from, right? And so just proof of stake, I don't think we've seen any production implementations yet that are actually like solid and valid. And so hopefully as we deploy proof of stake blockchains, we'll slowly start to learn like where these constants should lie. And so for the Cosmos Hub, which is one of the chains we're building, we're setting the limit at the minimum inflation is 7% annual, and the maximum is 20% annually. Yeah. So if it's 0% of stake is staked, then the inflation percent is at 20%, and once it gets to 67%, it drops to 7%, and then it just remains constant for the rest at 7.
If the currency does get super devalued in the future, does that mean that there's less at stake? You know what I mean? Just like from this nothing at stake problem perspective, like if the currency gets too deflated, will people care if they lose those tokens?
Yeah, because they have more tokens staked, right?
So it's the same
Same
value.
economic value of stake. Yeah, each individual token is less valuable, but the amount of tokens that are staked are increasing, right? So if you want to learn more about this, so if you want to learn about all of these like features like instant redelegation, whatnot, watch this talk. If you want to read about this multi-token model thing, like I have like a much longer form explanation justifying all of these things. This is a paper I just submitted for a conference. So don't like tweet about it yet because I don't want the conference people to get mad. But if you want to read it yourself, you can read it there. And then this is another paper that was talking about the efficient token distribution, reward distribution. Not sorry, that's a typo. It should be reward distribution. How do we make sure that validators don't run away with delegators' funds, but how do we do this in a computationally efficient manner? Without like iterating, because there might be millions of delegators. We can't iterate over every delegator, every block in order to give them their rewards, right? So we need to, this is just interesting from like a computer science perspective of how we implemented this. All right, yeah. Any more questions, final questions on this proof of stake? Yeah.
I hear about this game of stakes that happen over time, like game of stakes 1 to whatever.
Yeah.
What is that? How is that directly tied into anything that you're doing?
Yeah.
What are you guys learning from those game of stakes?
Yeah. So in game of stakes, what we were doing was, it was a test net for our Cosmos Hub blockchain, and the idea there was I don't know, it was a weird idea. The idea was let's simulate a long period of time in a short period of time. So let's like make the inflation percentage instead of like 7 to 20%, we made it like 10,000% annually or something in order to like mimic like light speed over long periods of time. And we just wanted to see what kind of attacks happen in practice. And we were actually pretty happy because a lot of the cartel attacks and stuff just weren't able to happen because validators are actually competitive enough that they don't cartelize. And so that was very interesting that we just got. It was just a mechanism of, it did two things. Game of stakes, it helped like test some of these proof of stake mechanisms, and two, it just helped test our software.
Is that like the same thing as the Gaia networks?
So Gaia is the name of the software that the hub uses. And so yes, the game of stakes was a testnet running Gaia. Cosmos Hub is another chain that's running the Gaia code base. Does that make sense?
Yeah.
Cool. Yeah. I'll get into a bit of game of stakes later. Okay, cool. All right, next up, Cosmos SDK. So let's go back to our generations system. Generation 1, if you want to develop your own blockchain, got to fork the Bitcoin code base. That's, just a recap of what we were saying. Ugly spaghetti code, C++, very monolithic stack. So everything's in this like one code base, and there's like consensus logic mixed up with state machine logic and stuff. It's like, especially things like SegWit makes it even more like, and because of that, it's like, even if you fork your code base, you have full control over it, the sovereignty aspect, but you just don't have, it's very difficult to work with. It's hard to make anything very advanced, which is why basically every early blockchain project was just a slight fork on Bitcoin, changing the monetary mechanism or changing the hash algorithm, nothing very fancy. Ethereum, like I said, easy, Solidity makes it super easy, or super easy, but easier. Yeah, we already went over all this. It just makes it a lot easier. But you lose out on the sovereignty and all the stuff we talked about. So, Cosmos SDK. Here the premise is, let's build a framework for making it easy for people to write your own blockchains. And the idea is you're writing it in native code, it's in Go, you're compiling your blockchain code base and then running it as part of the client code. It's not running on this Turing complete VM. It's, these application-specific blockchains, like, smart, so this is what I was saying, smart contracting is useful, and I'm a big fan of smart contracts, as long as that they're used as they sound, as contracts. If you need to make a one-time contract, if you need to make a short-lived thing, like smart contracts are great for that, but they're not great for dApps. You don't want to deploy DEXs, write DEXs in smart contracts. You don't want to write prediction markets in smart contracts. You don't want to write these complex systems. ICOs were the perfect use case for smart contracts. They're a short, one-time use thing that's very short-lived. That was a perfect use case for smart contracts. But now we start people seeing deploying Augur on Ethereum, and it's just it's not working. So most production dApps don't actually need a Turing complete VM. You know the application logic, you write it in core code, and then you deploy it. Having these application-specific blockchains, it reduces the attack surface. You don't have to worry about the complexities of the VM, which essentially caused the DAO attack, both the parity bugs, etc. You get the efficiency gains due to lower computational overhead. So that EVM has about 100 opcodes. Let's say you just wanted to make a simple storage system, right? Nothing else. You don't need that many opcodes. You can you reduce the complexity. It's all compiled rather than interpreted, and you can fine tune to optimize for your application. So Bitcoin uses UTXOs because UTXOs are better for payment systems. They can be parallelized much more easily than the account model. But if you use the VM, you have to use what they tell you to use, which is like the account model. You lose out on that ability to fine tune, to optimize, and the customizability we were talking about. So the Cosmos SDK, it's a framework for building blockchain applications. You can think of it almost like the Ruby on Rails. Like the goal with the Cosmos SDK is to do what Ruby on Rails did for web development. It provided this very easy to use web framework that had a lot of packages or gems, and that you can combine into like making more complex web apps. And so it's completely open source and available on GitHub, and it has this concept of like it's a very modular architecture. So you can pick and choose pieces from like these modules and fit them together to create your own blockchain. These modules are secured by this thing called principle. It uses principle of least authority using this thing called object capabilities. If anyone's familiar with those, but it's fun security stuff. You can look into that. But yeah, and so the idea is you can use modules that other people have already built, or you can build your own modules and hopefully open source them. Well, you have to open source them if you want to deploy your chain, but and downstream them to enrich and contribute to the Cosmos ecosystem. So we can see what I mean by this. So we have these like core modules, which are we have accounts with coins and everything. We have that whole automatic reward distribution. Our entire bonded proof of stake mechanism that we proposed, we have it implemented in our staking module, slashing, IBC I'll get into, governance, we have like on-chain voting and everything. And like I said, I'm pretty conflicted myself on on-chain governance, but so if your chain you don't want to use it, you just pop it out. You don't have to use it. And so one of the chains that we're building is called the Cosmos Hub. It's really just a mechanism of dog fooding our own software. And so it uses the core modules. Oh, also Tendermint is like you can think of it as a module in the SDK. Tendermint is cool because you can use it as both because it's in Go, you can use it as a socket protocol or with anything. But if you have your state machine in Go, you can actually import it as a library. So that's kind of cool. It's our core modules plus an extra module called Peggy. Ethermint is like the core modules plus this EVM module that we're writing and this like shared security module. There's a project called Iris Network. They're doing some like microservices stuff that they're writing modules for. There's a project called Lino where they're like adding some like an auctioning module, a bandwidth fees module. They have like a reputation module that they're building. Kava, they're a team that's like writing a lot of payment channels modules and like some modules to interact with the Interledger protocol. Fourth State is a team based out of Blockchain at Berkeley. So for example, they're using our Peggy module that we originally created for the Cosmos Hub, but they're like because it's an open source ecosystem, they're using that module along with their own Plasma module that they're developing. And so the idea is like there's so many more modules that are yet to be built. This slide is actually a little bit old. We have some people already building like DEX modules and stablecoin modules and oracles and stuff. So there's a lot of cool stuff to be built and enrich this module ecosystem. And so the idea here is, the efficient state machine, all those benefits of application-specific blockchains instead of pure and complete VM. You get a lot of the customizability. So, the accounts module that we use actually does use account numbers, but you can also use the SDK to build a system that uses UTXOs. You have that full customizability there. It's easier to develop. Go is just way better than Solidity. It has like so much documentation around it, tooling, linters, IDEs, and a 10 billion. I don't know how much Google is worth. Like multi-billion-dollar company pouring billions of dollars of resources into developing this toolkit instead of having like 5 people at the Ethereum Foundation developing Solidity. and then it helps with the scalability aspect from the application-specific side that we talked about. And some more resources. So this SDK tutorial is this talk is part of a series. The third section, we're going to actually be doing going through this tutorial and building a sample module, a sample application on the SDK. So that's the link if you want to, get a head start or something. Here's the repo of the Cosmos SDK, and this is a blog post by Gautier, one of our coworkers. Just a longer form exposition on the case for why application-specific blockchains make sense. Cool. Any questions on the SDK? Cool. Oh, yeah.
How long before mainnet launches, do you think?
I'll get to that when I get to the Cosmos Hub section. Yeah. Yeah. And so the next two sections, sessions of this series are going to be focusing a lot on the SDK. So the next one, Aditya from Fourth State is going to be coming and showing how he built a Plasma module on the SDK, and then the next one will be the tutorial. Then this is just sort of some of the other stuff that we work on, like more of the lower level lib stuff. We have like a protocol. We have a encoding standard called Amino. It's basically like what we claim is an improvement on protobuf. It makes it easier. Like it's deterministic, which is nice. And then it naturally supports interfaces instead of using one-ofs like protobuf. And the cool thing with this is you can actually generate your proto files, your amino spec files from Go code. So instead of having to write like protobuf files and then like having like the translator structs in Go and then like your actual operational structs in Go, you can just write your code and then Amino handles the creation of the tooling for you. It's just this nice developer tool. We do a lot of just hacking on side developer tools, and this is sort of like one of them. Another one is the IAVL plus tree. It's a self-balancing AVL tree where all the values are stored at the leaves, and it's immutable and so it updates using snapshots and caching. That's where the I comes from. And the plus is from the values being stored at the leaves. All operations are log n, and no hashing keys is required. And so this is actually super important, which I don't think a lot of people realize, and I did not realize. For years, I have wondered why Bitcoin does not have a state tree. Why does it not make a Merkle tree of all the current, sort the current UTXO set and make a Merkle tree out of it? This would help a lot with proofs of non-inclusion. You can prove that a UTXO has been spent or has not been spent yet to a light client. This is so useful, and it makes payment channels much simpler and whatnot. And so I was always just so confused, and I've never seen a good explanation for why they don't do this. And one of the Bitcoin Cash devs, Amari Sachet, who I'll be doing an Epicenter episode with this week. So he's the first person who finally gave me a plausible explanation. Here's the reason. This is sort of like a tangent, but I don't know. I just find it so cool, so I'm going to go on this tangent. What happens is if you want to sort the Merkle, if you have a sorted tree, Bitcoin UTXO IDs are hashes as well, right? And so they're being inserted randomly into this tree. And because of this, every time you insert something into the key, you have to re-Merkleize it, and you have to get all the inner nodes and do all this re-Merkleization. If you, as your state becomes bigger, you're going to stop being able to fit this in memory, and you're going to have to start writing this to disk, some of your inner nodes to disk. And now, because it's random, there's no caching strategy that you can use in order to kind of cache things, some of the inner nodes, and have some sort of predictable system. If there's no caching strategy and you're just constantly reading from disk, the system is just going to become so slow. Ethereum has this same problem. With their Patricia tree, they hash the keys and they write it to disk. And I claim that this is one of the biggest problems with Ethereum's state model, and it doesn't allow it to scale. The TurboGeth team has been doing a lot of work to improve this, but I just think that when you explain this to me, I'm like, oh, that's so cool. I've never thought of this before. And so the cool thing is we don't hash our keys, so we don't have this problem. You can have an efficient caching strategy, and you don't have this state bloat causing an issue with disk reads and writes. Cool. And then we do like a couple of other cryptography stuff. Like, we have our own library with amino support built in, some cool multi-signature methods. Some of our interns have been working on, like, from last summer, we're working on some BLS aggregate and aggregate signature work and some implementations and a verifier in the EVM. So this is just sort of like, other cool stuff that we just create open source work for. And we also have I'm not going to go into that. Yeah, so some of the the low-level libs, it just helps build stuff a lot easier, especially that cryptography library that has amino support. It makes it the development process makes it a much easier, and the whole IAVL tree with the no hashing, I think, adds to the scalability benefits as well. Yeah, and you can read more Go Amino repo, IAVL repo, and the BLS repo. The SDK was a framework for building your state machine, right? Like, you could write your state machine from scratch if you wanted to, and a lot of people do. Like I showed you, like, all the languages we have, like, people have already built stuff in. Most of them were just built using, like, bare metal state machine code bases. But the SDK was meant to, like, it provided you a nice framework, this modular system to make it easy to write a state machine in Go. But it's not going to be the only framework. And so we already have a internally developed secondary framework called Lotion.js. And so, I don't know, it's kind of probably hard to read from where you guys are, but it's like super simple. It's this nice framework that allows you to write your state machine in JavaScript, and they're building their own little module ecosystem. It was created by two of our engineers, Judd and Matt, who recently just like spun out and created a company called Nomic, still being funded by the ICF, by the Cosmos Foundation and whatnot. So, this is really cool, and I think, like, the use cases are different. If I'm going to be building a high security system, I'm still probably going to use Go, not JavaScript. But I think there are people out there who maybe will prefer the Lotion.js framework rather than the SDK. There's also one called IOV Weave. Weave is a fork of the Cosmos SDK. So one of our lead engineers, Ethan Fry, he used to work for Tendermint, and then he left about a year ago now. And so when he left, he actually took the version of the SDK he was working on and kind of forked it and kind of had his own little vision for it. He really wanted to make it much more simpler. Our SDK is very feature packed and, like, has all these cool things. He wanted to do it as simple as possible with, like, limiting a lot of the features. So I think it's a really cool framework as well. So there's that framework, and like over time, the idea is we can add more and more frameworks. So one of the things I really want to do is take Parady's building a framework called Substrate in Rust, and I think that would be really cool to, we can just take any framework, put an ABCI wrapper on it, and have it run on Tendermint Core. And that's really cool. So that's something that I'm going to be looking into in the next few months of how to use Substrate to also create Cosmos chains. And yeah, so benefits here, you get the whole efficient state machine, customizability, easier to develop. Here's the link to the Lotion.js repo, and here's the link to the IOV Weave repo. Cool. And Ethermint. This is this is kind of a framework as well as it's a chain that we're building. Ethermint's kind of complex. So Ethermint, what we did was, if you remember from the previous slide, what I showed was we just took the EVM and ran it on Tendermint Core. We literally took Go Ethereum, Geth, stripped out their mining logic, and just ran it directly on Tendermint Core. This is cool. We had Ethermint working and everything. But the problem is, all of these staking modules and stuff that we've built, spent a lot of time implementing in the Cosmos SDK, we couldn't really use that in our Ethermint. We would have to rewrite our staking logic and figure out where to fit it into Geth. So instead, Ethermint 2.0 is we just created an EVM module inside the SDK. And so, it handles all the account databases, state trees, uses the same RLP encoding that the EVM uses. The cool thing, you can make calls from the EVM module into other SDK modules, and to the EVM, it just looks like a precompiled call. So, you can have a precompile that's like, make a vote, and you can just call go, and it'll call the governance module in the SDK. So this is really cool. And so, you know, you get the best of both worlds here if you are still using, like, let's say you already have a project that you spent a lot of time developing and, like, you know, you already spent a lot of resources investing into, like, Solidity code development. So you already have something. You get, like, the scalability of Tendermint. You get all this modularity of the SDK. You get to use the existing ecosystem of Ethereum contract and dev tooling. And you get the EVM module from TurboGeth. So we've been working with Alexei from TurboGeth to take a lot of his, like, you know, massive improvements he's done to like, you know, the underlying state stuff and, like, database performance improvements and whatnot. And so we're adding that. And the important thing is it is Web3 compatible. So there have been other previous implementations of EVM on Tendermint. The most famous one is by a company called Monax. It's a project called Hyperledger Burrow. So that is an implementation of the EVM on Tendermint Core. Problem is, it never did Web3 compatibility, and because of that, it just never really took off. But now that we have Web3 compatibility in this, you know, it works with, like, MetaMask and Truffle and, like, all the tooling that exists right now. And so if you want to use Ethermint, you really need that Web3 compatibility. Yeah, you know, these are some of the improvements that Alexei has been working on TurboGeth. You know, not going to go into it. There's two ways to use the EVM module. You can use it as a blockchain on its own. So, you know, you can just run a blockchain that has just the EVM module and some other core modules and just say, and you can just use it like you use Ethereum today. Or you can use it as a library where you can deploy your own Cosmos chain with EVM support. And so then you can, like, you know, this is useful because maybe you need some level of contracting capabilities for your users, right? But you want your core logic of your application to be in Go, but, like, you want your users to be able to deploy some logic in Solidity. Or you also get like, you know, you can use it as a modular upgrade path. So let's say you're a project like Augur. You've already spent a lot of time deploying your entire thing in Solidity. What you can do is you can launch it as a chain where currently all of your logic is in the EVM, but then over time you can, like, start moving certain pieces out of the EVM and into core SDK modules and have it be this, like, slower process of shifting over. So, like, you know, in Augur you can start moving your, like, you know, betting system out, then you can move your Oracle system out, and then you can move your, like, you know, marketplace for the rep tokens out or whatever. So it also provides, like, an interesting upgrade pathway for existing Ethereum-based projects. Yeah, it's kind of a repeat of what I've said. And so, you know, this really helps, especially on the, you know, it helps the TurboGeth improvements help make the state machine way more efficient than Ethereum, mainnet Ethereum. You get that customizability because of the library and stuff. You can, like, now you can add your own precompiles, and it's very easy to write precompiles by writing them as modules. And you get that whole, like, one-click deploy that you already are familiar with Ethereum. So this is a presentation one of my coworkers, Chris, gave. Yeah.
We've been talking to Augur and other Ethereum dApps to basically tell them about the benefits of transitioning to Cosmos.
Yeah, definitely. We've been, you know, in touch with a lot of these projects, Augur, Gnosis, Maker, like.
What do they say?
Most of them are definitely interested, and, like, especially when pitching this, like, slow upgrade pathway, I think that's what got people very interested. Where, you know, I think for a lot of these major, that's kind of why we, like, originally we were only thinking of Ethermint as, like, a chain that we're deploying, right? Like Ethermint where you deploy stuff, and then we thought Ethermint and then Cosmos SDK are separate, and, like, but then, and, you know, we really wanted to help people push towards the SDK. But that really, like, freaked people out. Like, we're not going to go rewrite our entire stuff in that. And so now that we pitched this, like, slower upgrade process, people seem to be pretty open to it. And, like, you know, a number of projects, you know, I think Shapeshift is definitely one of, like, the, like, Shapeshift, they have the whole, I forgot what it's called, that product of theirs, but, like, some they're deploying on Ethermint and, like, using the EVM, but slowly starting to write stuff in the SDK modules and stuff. Yeah. And then, so, you know, a couple of people who are using, oh, by the way, some people who are using the SDK, like, recently Binance announced that they're building their DEX using the Cosmos SDK, which is pretty cool. Yeah, so like I said, presentation from Chris at DevCon, kind of going through Ethermint and explaining that, and then here's the repo that you can take a look at. And now finally, probably the thing that most people, yeah.
Sorry, I had a quick question on Ethermint. So we've been following it pretty closely because the project we're working on, this would work very well for us. But saw that there hasn't been any development now for like 2 months or so.
Yeah.
I was curious is this still part of the y'all's plan? Is it
Yes.
being
Sure.
reevaluated? Just curious there.
Yeah, so what's going on there is the Cosmos Hub was supposed to launch in December of 2017. We are now 14 months delayed. And so what we've kind of done in the past couple of months especially is like all engineering resources are shifted towards like focusing on the launch of the Cosmos Hub. But now that that's going to happen within like next 2 or 3 weeks, we're going to shift resources back into Ethermint and other stuff, yeah. Yep.
Another thing is because Ethermint is supposed to be a module in the SDK needs to be feature frozen first before.
That makes sense.
Oh, right, yeah, that too.
So if you want ERC20 functionality, do you deploy Ethermint or do you pick some other route?
So by ERC20 functionality, it depends on what you mean by that. If you're talking about you literally want ERC20s, then yes, like you need to deploy an EVM module. If you want a custom token, the SDK provides a mechanism for you to have tokens, and like you can have as many tokens as you want in the chain, and each token is native. Like the ERC standard of doing tokens is very bad. Like as a contract, it's not like it does. In our system, in the SDK, it allows you to have unlimited native tokens. And so that allows all these tokens, like I said, to be used to pay for fees and whatnot.
What's the development process? Because let's say with Ethereum, you just inherit from an ERC20 token, flatten it out, compile it to bytecode, deploy it, and you're done, right? How do you do that?
So keep in mind, here we're talking about application-specific blockchain. So the idea is you should, whatever token you need, you should have deployed it when you deployed your blockchain, right? But you're not going to add a new token on later. Does that make sense? But you can have mechanisms that, like, modules that allow people to mint tokens. So I can have a module called Minter, and what I can do is any user can just send a transaction saying like, hey, make a new native token called Sunny token, right? And it will do that, and it'll create it as a native token and everything.
So the thing to research is the Minter module,
Yeah.
and how to create tokens with the Minter module. And there's some sort of a spec with like a transfer and balance of that gives you a template to start off, or you have to figure that out yourself?
We're working on that. There's a sample Minter module in the demo coin example in the SDK repo, but like I said, that is definitely needs a lot of work. We've kind of built all these sample modules we used to be building, kind of all on pause right now, waiting, like focus on hub launch. Another cool sample module that's on there is this proof of work module, where what it does is like so I'm personally of the belief that proof of stake is better for consensus, but proof of work is better for coin distribution. Cause like everything that you were saying about like, I think proof of stake is too centralizing for monetary distribution. If you wanted to try to take your shot at like making money, I would say still use proof of work, but you can, so we have a module that like people can submit these hashes and it mints coins for those hashes. And so, you can write modules that like emit coins and things like this.
So with you probably know Open Zeppelin, right? Is a repository where you have dozens of contracts that you could look at. For example, like you want an escrow, here's how you build an escrow. You want an ERC20 token, here's various versions of that with minting and rolls and all that. And I'm wondering if the modules are the parallel of that.
Exactly, that's what the modules are the parallel of. Although the one thing that's missing, the one thing that's missing right now is we don't have the like common repository yet. Like, so the thing with like Open Zeppelin is all in this one GitHub repo. It's very nicely organized, right? Right now, that the modules are supposed to be exactly that. It's the equivalent of that, but we need some mechanism of like organizing them and like, maybe some website where developers can like upload their modules. And then there's also this question of auditing. Like, we need some mechanism for like people to read these modules and basically like maybe assign some stake to it and basically say like, oh, I'm staking my reputation because I audited this module.
Conceptually, is that going to be, modules are going to be Go code that you pull down, compile, and then redeploy to Cosmos? Is that
To your own chain, yeah.
Okay, so it has to be to your own chain as opposed to a public chain like Ethereum or EOS, for instance.
Exactly.
And that is it's two different approaches to deployment basically,
Exactly.
right? So you're never going to deploy to a public chain
No.
with Cosmos
No.
or with an Ethernet tokens.
Yeah.
Or
Or you
Tendermint
can upgrade the
tokens.
public chain through governance or some whatever mechanism, right? You can say that like governance can choose to add modules, but that's like hard fork upgrades, right? Not hard fork. It doesn't have to be hard fork, but those are upgrade processes. It's very different than. It's not like Ethereum where you're uploading code and running it. It's application-specific blockchains. You know your application and you're writing that code and you're deploying the application, not like, yeah.
So just another quick question. So I guess another concept that I think about is when you're dealing with a public blockchain like ERC20, if your company ever goes away, hypothetically, somebody else may step in and make use of the existing tokens that are out there floating that people have private keys to. Does that concept not apply to anything?
No, it applies completely here as well. It's like, it's the same. It works the same way here. Like, think of it similar to like some of the early, like the Generation 1 blockchains. Like just because they're application specific doesn't mean they're not public chains, right? Like for example, let's say Namecoin, right? Namecoin was originally developed by like what's now the Blockstack engineering team, right? But that team stopped working on Namecoin and instead started working on Blockstack, right? But Namecoin never died because it's this public project that like other developers took over and like continued developing it. Just because something is application specific does not mean that it's controlled by one company or it's not a public system.
I guess what I imagine is when you have a whole bunch of validators that have their own private keys and one company controls that if that disappears.
It doesn't. But those validators don't have to be run by one company. All of your chain can be secured by a proof of stake system, right? That like you have your own token that you use as a staking token, for example. And
So you basically have to kind of build up a community that's going to, which is going to take responsibility.
Yeah. And we also have alternative mechanisms if you don't want to build up your own community, which I will get to in I think the next section. Yeah. Cool. Okay. All right. This is probably the one thing that most people know Cosmos for and what we're probably most famous for, which is IBC or inter-blockchain communication. Essentially, what's going on here is we're able to use it's just a continuation of the sidechain protocol that was like kind of originally conceived by Blockstream back for like 3 or 4 years ago, back for Bitcoin. But a lot of the developments that we've done help make it a lot easier, especially Tendermint. So one thing I did not mention in my Tendermint section is Tendermint is very efficient for light clients. Light client, you can the problem with proof of work light clients is you need every single block in order to verify the head of the chain. In Tendermint, that's not true. You can actually do light client security by jumping a number of blocks. You don't need every single block that ever came. And so the thing is, when you have two side chains that are communicating with each other, let's say like there's no packets going between them for like hours, right? You can actually just send the most recent block as long as the validator set did not change by more than 1/3. And even if it did, there's a efficient bisection algorithm that we use to how you can transmit the fewest number of blocks necessary. And in a proof of work sidechain, on the other hand, let's say there were thousands of blocks that went by. The next time you transfer a packet, you have to send every single one of those thousands of blocks, and that's just not very scalable for you can imagine why. And then the light client's also nice, just even minus the for IBC, it's just really nice from a user perspective. If you turn your phone off for the night and you turn it on in the morning, there's probably about 50 or so Bitcoin blocks that went through it in that time. I've checked my phone can do about 3 or 4 SHA-256 hashes per second, so it'll still take me about 10 seconds to sync up to the chain. That's Bitcoin, who has 10-minute blocks, and SHA-256 a very easy hashing algorithm. I've never actually tested it with Ethereum because there are no Ethereum light client, mobile light clients as far as I'm aware. But 15-second blocks, very complex hash algorithm. It'll probably take me a few minutes just to sync my light client up to the head of the chain on my phone, which is off for one night. And Tendermint just, it makes it way faster. You just jump the blocks and then you do a couple of signature checks. And these signature checks will get way more efficient once we do the BLS aggregation I was talking about earlier. So essentially what's happening here is you are basically, two chains are light clients of each other, and you send this packet between them, and it proves state. So something happens in chain foo, and it's logged in the state somewhere. You send a message. You make this packet format out of it, and a message relayer, which is some node that will be incentivized some way, which is still one of our main focuses of research right now, how to do this incentivization. But they'll go ahead and transfer it, relay that packet to chain bar, and chain bar will have some mechanism of acting upon that. And then it will send a confirm message back to chain foo, and then chain foo can act on that return message however it wants, maybe deleting that log event from its state so it doesn't just fill up its state with thousands of log events. And so this is equivalent to application. It's the IBC itself is similar to the TCP IP stack, but on top of this you need, just like in the internet model, you need the application layer. And so just like in the internet, you have application protocols like HTTP for web, or SMTP for email, FTP. You have all these FTP. You have all these different protocols on top. And so you're going to need to do the same thing for IBC. We're going to have to design these higher level protocols. So the one that we're starting with now is just simple token transfers, because we think that handles the majority of the value. And so how that works is, what you do is you lock up coins here, you send a packet to chain B and basically say, hey, look, here's proof that these coins are locked up and cannot be moved. B gets that packet and you unlock the coins. And what you can do later, if you want to go in the other direction, which I don't have the animation for, unfortunately, is you burn these coins and then you send a packet to chain A saying, here's some proof that I actually did burn these coins. And then chain A will say, OK, cool, I'll remove the lock on these coins for you. And you get the coins back. And so really what these tokens are here is they're a claim to the locked asset on this chain. And so that's essentially acts as token transfer.
Yeah. So if I want to spend on B, if I use those coins for something, do it then go back? Would I have to send a packet back to A and tell them hey, you need to decrease the lock funds?
No. So well, if you want to send, let's say you want to send it to someone on B, right? You can just send the asset directly, because the asset it's a bearer asset on the claim to the underlying locked asset. So I could send. So I locked these coins. I got them here. I can send them to you, and then you can be the one to burn them here, and then these will get sent to your account here. So when you burn them, you tell this protocol which account to send the locked coins to. So you can use that for token transfers, which is what we're focusing on now. You could use it for non-fungible assets, or NFTs, as people like to call them. You can use it for data, like oracles. So you just have some data, prove to me that something happened on this other chain. I think private chains can serve as very valuable oracles for public chains using this method. And then there's this thing called Agoric, ERTP, stands for Electronic Rights Transfers Protocol. This is something that I realized, I've been thinking about for a little while. What's happening here is, in our token transfer protocol, these are just claims to underlying tokens, right? They're not the token themselves. And this is fine for most assets, because really, if an asset just has value, doesn't have if the asset's value is just it being a bearer, if the underlying thing is a bearer asset itself, then it's kind of fine if you just have a claim to an underlying bearer asset. So if you locked Bitcoin and you had this and it's always one-to-one redeemable, it's essentially as good as Bitcoin. But then the question the thought I had about a year ago was what about a CryptoKitty? I can lock a CryptoKitty and have a bearer have a claim to that underlying CryptoKitty, and let's say this is a DEX chain. I can trade my CryptoKitty and do all sorts of fun stuff with it. But here's the thing, CryptoKitties is, one, it's a collectible, but it's also a game. Like there's this game where you're trying to like breed the CryptoKitties and like have them have new CryptoKitties and stuff. You can't do that on this though. If you have your CryptoKitty here, it's not actually the CryptoKitty, it's a claim to a CryptoKitty, and you can't breed the claim to a CryptoKitty, right? If you ever want to play the game, you have to move, burn the claim and unlock it here, and all the breeding logic has to be done on the original chain, which isn't, it's not as fun. I want to create, and especially, CryptoKitties is like a toy example, but you can think of it as like a maker CDP, for example, right? What if you want to, exercise that maker CDP on another, or execute the maker CDP on another chain, or let's say an options contract, right? An options contract, it's a contract, but at the same time it can be an asset, and maybe you want to be able to move that options contract to the asset itself to another chain, and then still be able to exercise that option on another chain without having to go back to the original chain every single time. And so, Agoric is a team that's been like working on this for the last like 25 years essentially, how to do like data and logic transfer across chains, and they have this cool object capabilities approach. So definitely check them out if you're interested in that kind of stuff. And so, we're helping them like experiment with building this on top of IBC as well. It also helps from the scalability perspective. This kind of goes back to the application-specific chains as well as like the IBC. If you think about it, this is sort of a type of sharding where we're essentially taking, instead of putting everything on one chain, we're kind of spreading across multiple chains. But it's a special type of sharding. I call it application-based sharding because it minimizes the bottleneck. The bottleneck in application-specific chains in any sharded system is how much inter-shard communication there is. So if, let's say the EVM, Ethereum, last I remember from their proposal, they were going to shard by address space. So if the first byte of your address is 1, you go to this shard. If it's 2, you go to this shard. If it's 3, you go to this shard. The problem with that is that makes it, let's say you're just as likely to communicate with anyone else. Now there's a 15 out of 16 chance that your transaction is going to have to talk to another shard. And now you have so much overhead going over the relay chain or whatever you have here. And that is not just very scalable. Application-based sharding, my theory, my claim, is that most transactions within an application stay within that application, and the vast minority of them go to other applications. And I think that's just a logical idea where you have a DEX. Most of the transactions are people trading on that DEX, and then the minority are people like withdrawing from the DEX and stuff like that. So I think the application-based sharding minimizes the bottleneck, which is inter-chain communication. Yeah?
Do application chains also maintain liveness independent of one another? Like if there's some halting issue somewhere, does that? Okay.
Yep.
So that's also.
Yep. Right now, up till now, what I've proposed is all of these chains are sovereign. They have their own validator sets and everything. Yep.
Okay. So in that, I guess, an extension of that, do they help secure one another in any way?
Not right now.
Okay.
The other thing is, you guys may have heard of like Vitalik's like scalability trilemma, which is like, you can't, splitting stuff across multiple chains is the equivalent of a block size increase. It's not actually a scalability solution. You can't just say, oh, I have one chain and has X throughput. Let's just make 10 chains so it has 10x throughput, because now, it's really just the same as increasing the block limit of one chain to 10x. One, that's not true because of like parallelism, where like, if these chains are relatively isolated because of their application layers are distinct, you can run them in parallel, and scaling out is much cheaper than scaling up. So that's one thing. But also the thing is, you only have to be a user for the chains that you care about. So let's say I'm a user of Saya, but not of 0x, right? I don't have to run the 0x chain. And no one's actually a user of every single dApp that's in existence. And so once you split by application, you're making it easier for people to only validate and run nodes of their services that they actually use, rather than forcing everyone to run a node of everything and validate everything under the sun, right? And there could be some validators who say, oh, it's their job, they have a company around it, they want to validate every chain. But as long as they'll have like a server farm or something somewhere that's doing that. But as long as the users aren't the ones who are validating every single chain in existence, I think that like the trilemma is way too abstract in its thinking and doesn't consider the practical matter of that like users actually have preferences of what chains to use, and they're not trying to validate everything. I think it also might help, Tendermint. We're very much interested in this like idea of like localized chains. We think that in Tendermint Core and Tendermint BFT, the limit, like I said, we push it as low as possible, and so the limit really is the speed of light and like how fast you can do BFT consensus over the public internet. And it takes time to go from here to here. But if you have localized blockchains, like in a certain region, the validators are more localized and closer to each other. You can do much faster block times and higher scalability. You can also do like I said, it kind of goes with the whole sovereignty aspect I mentioned with like LibraLand. If all the validators are in a close geographic proximity, you can get way more scalability that way. We have a project. One of our partners is called Iris. They are building a chain that's focused on just China. And when I first heard about this, I thought that this is like, this is kind of scammy. Like, it's just like Neo or the Chinese Ethereum. Oh, is Iris just the Chinese Cosmos or something? But no, but then I actually like thought about it. I'm like, okay, I actually like this idea. It's very interesting because I'm worried about the Great Firewall of China. And if the firewall suddenly comes crashing down and says like, oh, we're like censoring packets coming into and out of our system, that's not good. And Tendermint, it's fast and it can run over Tor, but it'd be nice if we didn't have to. And so, it'd be nice if we had, it'd be fine if we have a chain, a hub that's on the outside, and then we have a chain that's inside China, and they can communicate over IBC using and you can send IBC packets over Tor, but you don't have to do BFT consensus over Tor. That would be very nice. And so, I think that there's a lot of advantages to be gained from this sort of like geographic sharding, as long as you still have that interoperability there. But at the same time, it comes with like other like regulatory concerns as well. So now if validators are more localized in an area, that also might mean they're more in a common jurisdictional area, right? You don't, if you have a Europe chain that all the validators are physically located in Europe, now like does that mean now they have to start being GDPR compliant? I don't know. I don't even know what that means for a blockchain. So and then here's a user story I wrote a couple of months ago. It's kind of a fun example. So you can imagine you take your BTC from the Bitcoin blockchain that you're holding on to, and you can use it to like a casino chain, like a gambling chain, and like play some poker or something. And great, you won some money, and you don't want like your friends to know about your like degenerate gambling habits, right? So what you can do is you can go ahead and move it to a zero knowledge chain. So one of the projects I want to build is take the Zcash state machine, but remove the Zcash token, but just have it so you can move any token into this and use the zero knowledge properties of their state machine without the Zcash token. So I can move my Bitcoin into the Zcash chain and kind of use it as a mixer, or I can just keep it in there and use it there permanently, however you want to do it. But I can move it to the Zcash chain and send, use it as a mixer essentially and send my Bitcoin back to myself, and like, now I have some level of privacy there. Great. Now I have some extra money to take up my friend on that bet that he had. So, I made a bet with him that, we couldn't have a CryptoKitty, my CryptoKitty couldn't give birth to an orange CryptoKitty within 6 months. And so, this is a really long-term bet, 6 months. Bitcoin's pretty volatile. We don't want to denominate our bet in Bitcoin. So, what I'll do is I'll take my BTC, move it over to the Binance Dex chain and trade it for some DAI. Take that DAI, and now I'll take it to, send it to the Ethermint chain. And so here's an example where like smart contracts are useful. It's a bet. It's a one-time thing. We're not deploying an application here. So let's go ahead and write a smart contract that we'll put the DAI in the smart contract, and I can move my to settle the bet. I can take my CryptoKitty asset from the CryptoKitties chain, and I can send it to the Ethermint chain and prove it to the smart contract, and basically see like once it resolves, I can win the DAI or I cannot win the DAI. Like this is obviously like a bit of a toy example, but this kind of like shows the user story of like what kind of things you could do when all these chains are actually able to interoperate with each other and have their applications work together. Cool. So IBC helps with that interoperability story that I mentioned, and it helps with between these different dApps, and it helps with the scalability stuff, with like the geographic sharding and the application-based sharding.
Would IBC module be used for this?
Yes.
Or PEGI, or is that?
So IBC, the Cosmos SDK has an IBC module in it that you just use it, and your thing is IBC compatible. If you want to use a different state machine or a framework, we have to develop IBC modules for those frameworks. So, the Nomic team, Judd and Matt, they're working on implementing IBC in Lotion. And if like I said, I want to implement it in Substrate at some point. And if you're writing a bare metal chain, you're going to have to write IBC compatibility into your chain as well.
So you use PEGI explicitly for Ethereum integration?
Yeah.
And IBC is Cosmos or
IBC compatible to IBC compatible.
which is normally Cosmos related chain.
Sure, yeah. Hopefully it'll grow beyond. But yes, it'll be Cosmos, but like not just things that we've worked on. Like hopefully, we're working with Prismatic Labs. They're one of the ETH 2.0 developers, and so we're trying to get IBC natively included into Ethereum 2.0. So if Ethereum itself becomes IBC compatible, that'd be really great.
So Lotion, in comparison, you said there's going to be some IBC Lotion equivalent?
There'll be an IBC module in the Lotion framework.
Okay, and that would be different than PEGI?
Yes. So PEGI is for how do we deal with chains that don't support IBC natively. So Bitcoin, Ethereum, basically everything right now, right? Because nothing supports IBC. And so that's just a mechanism of, instead of doing two-way like clients, you instead actually have to have the entire validator set of one of the chains run a full node for the other chain. And that's kind of annoying, which is why PEGI isn't scalable to every chain. And the idea is, there'll probably only be PEGIs for certain chains, like probably like Ethereum and Bitcoin. And I don't know what else is any other. Only really high value chains are going to be worth it to deploy a PEGI for, because that actually requires all these validators running lots of stuff.
Are there any enterprise or permission use cases or projects?
Yeah. There's like I said, PBOC is using Tendermint for their stuff. Hyperledger Burrow is like all just an enterprise EVM chain. The Thai national government is using it for their national ID program. Clear Chain, I think it's called. It's a like live FX, public FX exchange, one of the biggest in the world. It uses it in their internal stuff. Yeah, so there's a number of enterprise projects. Honestly, I think there's actually currently probably more enterprise projects using Tendermint than public chains, because until the Cosmos SDK was ready, there was no good staking modules or any logic, right? And so the only way most people are just using Tendermint in a permission setting. But now that the Cosmos SDK is ready and we have a public proof of stake module available, now a lot of people are jumping in and like building public blockchains. And I can shoot you a link somewhere that has like a list of one of our community members has been maintaining a giant list of all the projects or that he knows of that's been are using the SDK for public chains.
And any enterprise using the IBC?
Oh, no. No one's using IBC. It's not developed yet. IBC is still in spec/prototype phase. Yeah.
Oh, another quick question. POA, right? So are they the same underlying technology? Like you mentioned them earlier, so I was wondering if
for POA, I was just saying that they are just like the only other team I've seen that actually has like something close to a production grade BFT engine, and they're using Honey Badger as their consensus protocol, not Tendermint. We can go into a discussion about why Tendermint versus Honey Badger and like what are the benefits and pros and cons there. But I think it'll be one of the ideas. We definitely, will have IBC abstracted so it doesn't care about the consensus protocol per se. And so that's how, that's what we're working with Prismatic on, making sure IBC is compatible with both Tendermint and Casper. And so, we'd love to work with the Honey Badger team on getting it compatible with IBC as well. But we haven't really reached out to them on that in that regard yet. Yeah, and so if you want to learn more, Chris gave a great talk at the ZK Summit last time. This one's a very technical talk. This one is a talk I gave at EdCon, also pretty technical. Kind of shows some of the, this goes into like a lot, both of these talks go into a lot more like technical details, like kind of explaining our spec for IBC, like, how we do packet relay, packet formatting, channels and connections, and how you open a connection, how you like do an initial point of like, how do you initialize a IBC connection between two chains. So, we have that in a lot of these. IBC webinar is Zaki. He did a webinar just like 2 or 3 days ago, kind of talking about like, the roadmap of where we are with IBC and like, what its status is and stuff. So you can check those out. Oh, this one has a lot. Here's the IBC spec, and here is a blog post about peg zones, and these are designed for PEGI that we were talking about. Okay, all right, we're almost done. Last mile. All right, the Cosmos Hub. This is a chain that we are currently actively building. It kind of serves a couple of purposes. It serves a purpose within the Cosmos ecosystem, and at the same time, it's also just a mechanism for us to dog food the SDK and like show a live public chain built on the SDK and like, have something there. So what are hubs? If we're building an internet of blockchains, and you can see we really like this internet analogy with the IBC and TCP and whatnot. Hubs can be thought of as the ISPs in this internet of blockchains, where instead of, the internet isn't a mesh network, it is a federated system, right? You have ISPs that are peered directly with each other, and usually you talk to the internet through like 1 or 2 ISPs that you have service with. This helps because it reduces the number of IBC connections to on the order of n rather than n squared. You don't have to have every chain talking to every other chain. And that doesn't mean there's only going to be one hub. There will be many hubs. Like we can see here that different hubs are kind of peered with each other. And Iris is an example of one hub. Cosmos, the Cosmos hub is an example of another hub. And there'll be more hubs in the ecosystem over time. But it helps like decrease the number of connections, which is good because it makes stuff a lot simpler. It makes it all of these zone chains, they don't have to keep doing light client proofs and keeping track of every single one of hundreds of other chains. Rather, these hubs are specialized blockchains, application-specific, specialized blockchains whose sole purpose is to just maintain a lot of IBC connections. They're not doing any other application logic. They're just making IBC connections and relaying packets between these zones. And so you can use this multi-hop system to reduce the number of connections, and it also acts as a secure medium to prevent chains from double spending each other. So what would happen here is let's say you sent a token from Bitcoin to Ethereum, and then from Ethereum to a zone. And then, but the thing is, Ethereum, let's say Ethereum is malicious, because those guys, they do DAO forks and stuff. They could just hard fork and say, nah, we're not going to take it we're going to take away the token from you and give it to ourselves or something. The idea is that the hubs should be very secure blockchains, high value blockchains, hyper secure, that kind of prevent as a double spend protection between other blockchains. So that's kind of one of the values of the hubs as well. And so this is the Cosmos hub. Sorry, lost track of. And just like ISPs that provide other services, hubs, ISPs do often provide web hosting. They often have their own DNS provider. They often do have some sort of security packages. I think hubs will also provide other services as well. They can provide governance services. So let's say this small chain became unlive, and they need a mechanism for coordinating how to fix it. You know, the idea is, like I said, these hubs should be the hyper secure chains, and hopefully they should be live. And so the idea is you can use, like, you know, they can use the hub as a coordination mechanism and message board to discuss how to do governance on their unlive chain. You could use it as a name service. So, it's a central point where, like, you can do like name service kind of stuff. So you can, or identity stuff. So you can have like common identity across many chains. Peg zones. So this is like the Cosmos Hub validators are essentially going to sign up to say, running an Ethereum peg zone is hard because you have to run full nodes for it, and it's not as simple as IBC. So the Cosmos Hub validators are going to say, like, okay, we'll take on the job of running these PEGI zones and like do that work there. And then the other thing is least security. And this means like, so this kind of goes to that thing about right now we're focusing on sovereign chains. Every chain has a separate validator set. Over time, we're going to have a system where, let's say you have a small chain, you don't have a big community yet, you don't want to find your own community and validator set yet. You just want that one-click deploy feature. By the way, this is like model of PEGI. We'll look at it later. So this is sovereign security, but then you could have replicated shared security, where the entire hub validator set can basically say, okay, we'll sign up to also validate your chain. And the same validator set can be validating multiple chains, and what will happen is like, when the validator set changes on the hub, it will also change everywhere else. And at the same time, if someone does a Byzantine fault on this chain, they'll also get slashed everywhere that they were a validator. And so that's cool, but it's also not as scalable. It's somewhat scalable because of the whole parallelism thing, but you can't have those same validators that can't run every chain in existence, or everyone who wants least security. So then you can have a system where like you have a large validator set, and there's a method called sortition, which means you randomly select subsets of that validator set. So you say like, let's say they're all running these two chains. Like, you can say, all right, half of you are supposed to be doing one, half of you are supposed to be doing the other. And if there's any fraud happening here, it gets pushed to the entire chain to like decide who was right and whatnot. It's faster with like smaller sortitions. There's slightly less at stake. And this is kind of like what, Ethereum, this is like now delving, kind of pushing into like Ethereum sharding and Polkadot style stuff. One of the issues I actually have, what I don't like about how Ethereum and Polkadot are doing like this sortition security, is they want to randomly select validators to validate chains. So let's say, your Polkadot, there are like, let's say 10,000 validators, and a new chain comes along, it will randomly select 100 validators and say, all right, you guys are all assigned to validating this shard. I would rather have a system in which chains can come along and say, hey, who wants to validate me? And then the hub validators can say, raise their hand and be like, yeah, we're down to validate you. Or another validator be like, the incentives you're providing here aren't worth it for me to validate you. I'm not going to. And so, it seems like a bit more just like free market. Let the validators decide what's worth validating for them. It also allows for like different types of validators, because there might be some validators who are like running out of their dorm room, and they only have the ability to run like validate like a couple of chains, while there's some validators who are like full-fledged companies doing this, and they want to validate thousands of chains, right? And so why are we stopping them from doing that? As long they're still putting their that seems completely fine to me, and I haven't figured out what's wrong with that mechanism. So that's probably the direction that the Cosmos Hub is going to start pushing into when it comes to shared security. And then also Plasma is just another type of shared security, in my opinion. And so the Hub will possibly, like, some of the stuff that Fourth State is working on, I think the Hub will start to act as a Plasma root chain where people can, like, use that for that purpose. So yeah, the Cosmos Hub, it helps the interoperability and like, makes the interoperability a bit easier. And when it starts to get into these shared security models, it will definitely help with this one-click deploy user story. And you can learn more about the Cosmos Hub. So you learn about like the interchain scaling. This is Jay did this at CSC. This is a great thread from Zaki on Polkadot versus Cosmos and kind of showing the difference of how we approach shared security. So that's a really good thread. And then just this intro on Cosmos, a lot of it's on the Cosmos Hub. So I think that's a good resource there too. And then these last ones are pretty quick. Voyager, we just needed a wallet and stuff and UI to make it easier for people to do stuff. It talks to the system through like a standardized REST endpoint that we kind of like hold. And then the idea is that most chains should support the same core REST endpoints. And so, using Voyager, you could do, voting on governance, you can delegate and everything and stake through Voyager. And really the point here is Voyager should just be like this like multi-chain wallet. So we're trying to get standards around these REST endpoints for different chains. And so the idea is that, hopefully it'll help a little bit with that interoperability story. And then I think Voyager will start to build in additional features around interoperability, such as like ILP support and whatnot.
Is it going to be like parallel to what MetaMask is or Scatter?
No, it's going to be more of a wallet and it's going to be its own UI and
So
stuff.
like standalone without any kind of dApp integration?
Yeah. Well, it's still to be determined. Right now, it is just a wallet that is designed to do like token transfers, governance voting, and staking for any Cosmos SDK chain that has support for these three modules. The future of Voyager, I'm not on the Voyager team, so I'm not too sure what their roadmap there is, but from what I've heard, they want to start having a system where like developers can write plugins for this Voyager system. It's kind of almost a, Ethereum, when it started, it had this project called Mist that never really took off. We should probably do more research into figuring out why it never took off. But it's kind of almost a recreation of that vision of like a common portal that you could use. And I'm not sure if that's good or not. Maybe the reason Mist failed was users don't want to use a new portal. They want everything to come through the web browser, which is why we're currently turning Voyager into a web app now. But and maybe like the MetaMask plus web browser model works better than a portal module version. I'm not sure. And so Voyager is just one application that's building wallets and tooling around this. Like we have a number, Iris is building their own wallets and stuff. There's a company called Lunamint who is building their own wallets and stuff. A number of the validators have actually started building like explorers and governance, like web apps that are like governance portals and stuff. You can do all voting there.
What was the outcome of the Ledger S integration that you guys were working on?
I think it works, from my understanding.
So basically,
I have a.
since you guys haven't launched mainnet, how many test tokens that end up being put in there, or how does that work?
Mm-hmm.
So you have Ledger Nano S, right?
Yeah.
So at this point, there isn't a token from
No.
Cosmos, right? So it's
So on Game of Stakes, for example, there's a test, which is a test net. It has its own token that we call stake, just called plain stake. And so that I've tested that. I can get it to work from my ledger and stuff. I can do transfers and everything.
so basically, there's some code somewhere where directly from Go it talks to the interface on the Ledger.
Yep. The CLI has native support for Ledger. It does all that. Yep. Cool. You can read the repo. You can check out. You can use the web app. You can use the Electron app version. You can use that, or if you want to try the web app version, you can like try it here at this link. And then some sample zones like Tendermint. We're pretty a lot of us. I really like building a lot of this like low-level protocol and infrastructure for the Cosmos ecosystem. But at some point, we also want to start building some like cool projects. And so, one of the things that a lot of us are interested in is like a DEX. Like I think there's a lot. Obviously, there's like the DEX space is way overcrowded already. Like hundreds of DEXs. But I think we have some. I have like a design for a DEX that I think is kind of cool. That's like I haven't seen anyone try to implement yet. So we'd like to build that, and I think it helps the ecosystem just having different types of DEXs. On that, let me actually like make an interesting claim as well about why I think Cosmos is important. There's different types of DEXs, and they all have different features and functionalities, right? So you can have the 0x model of doing DEXs. You could have the Uniswap model of doing DEXs. You could have the the Gnosis their Dutch auction model. You could have the Zexi zero knowledge model. There's so many, or you can have a Bancor style model of DEX, right? Atomic swap model of DEX. There's so many different types of DEXs, and I think what you want is actually everything in blockchain is about trade-offs, and there's often a trade-off between decentralization and scalability. Now, how many validators do you have? There's often a trade-off between user ease of use and security, right? Like Tezos, Michelson, their language is not very easy to use, but it's very well designed for formal verification. And I think most projects are trying to find all right, how do we find the perfect balance of all of these trade-offs to create the one solution? Cosmos instead allows how about we just explore the full range of trade-offs, allow each chain to have its own kind of trade-offs that it makes. You can have centralized chains working with public chains. You can have different types of DEX chains, and you can allow even let's say even if some of them take the majority of usage, you still have these smaller DEXs that have their niche uses. Maybe you have what do you call it when you have a dark pool DEX? You can have a dark pool DEX that's specifically for privacy purposes. You could have a Dutch auction DEX who's specifically for it's very slow latency, but it's you get the best possible price using a Dutch auction DEX. So you have all these different DEXs that have different use cases and niches and all being able to interoperate with each other. And so that's one of the reasons I really like Cosmos. It allows you to explore the trade-off space. Some other tools we want to build, fourth state, Aditya, he was an intern with us, and he's going to be joining full time, and still going to keep working on fourth state. Data availability, most zero knowledge snark systems require some sort of bulletin board for data availability, so building a chain to do that. Jay, he's very much interested in governance, and he thinks a lot about voting systems and discourse systems, and so he really wants to build stuff around that. Ethermint, obviously, we mentioned. And then we're also really interested in just blockchains are, all these dApps and stuff are cool, but really a lot of us got into it for currencies, because that's kind of cool. And so, we're really interested in monetary experimentation. I personally when I got into Cosmos, I was a huge Bitcoin maximalist, and I just got into it because my goal was to save Bitcoin, where I want Bitcoin to be the money, and it just flows out and becomes the money for all of these different chains. So you'll use Ethermint, but you paying your fees in Bitcoin. You'll use everything paying your fees in Bitcoin. Over time, I've become less of a Bitcoin maximalist, but not because I don't think Bitcoin, most people don't like Bitcoin because they think there's not much you can do with it. But Cosmos solves that. Once we peg to Bitcoin, you can use Bitcoin for everything you can use anything else for, ETH or whatever. I just think Bitcoin is going to fail from a monetary policy standpoint. I think the hyper-deflationary aspect of it just, I don't know, I think it's somewhat perverse, actually. And so, we're just very interested in doing some cool experimentation with monetary policy. We're launching a chain, we're launching a token called Photons, which is, one of the things that we're doing there is we want to experiment with fixed issuance policy, which means it's still inflationary, but it's not, it's still deflationary, but it's not hyper deflationary. It's 500 photons per hour till the end of time, and just experiment with this monetary policy. Turns out Grin actually is doing something similar, so they already started that, so maybe we should try experimenting with something different. And then we're something called hard spoons. What if we just start kind of like a hard fork, but it's really just forking a distribution and just creating a new token, kind of like airdrops. Just needed a clever marketing term for it. But so Photons, what we're going to do is, I feel bad doing ICOs and collecting people's money in order to do monetary experimentation. So instead, what we're going to do is we're going to take the Ether distribution, just copy it, and just start doing fun monetary experimentation with it, because no one's money is at risk. We didn't take anything from you to do this experimentation. I think stable coins would be really interesting. I think there's a lot of work already being done there. We had this design for stablecoin, and we jokingly called it a neutron because it's neutral and stable. I think UBI-based systems, I've recently been reading a lot about a project called Circles, and I think they have a really cool decentralized UBI model. Ethan Buckman, he is super into this idea called local currencies, which is this idea where currencies for specific cities, not even nations, and and you can do a lot of cool stuff there. Like, and he like advises. So he lives in Toronto, and he advises like this like project in Toronto that does this like local currencies thing there. And apparently like it's accepted places. I got a haircut in Toronto, and they accepted this local currency, which is kind of cool.
How did you pay?
I did not pay with the local currency. I just saw that they accepted it, but I don't actually have any of it. So, but yeah, but I think it was a crypto app, and
So it's like a citywide crypto app.
it's not city. Yeah, it's supposed to be for the city. It's not. It's accepted at a few. It's basically accepted at the few places where that team and Bucky like they went and evangelized it. But I think it's a cool idea, and I think it requires. This all just still boils down to that whole idea of smaller communities and like, can you get like interesting integrate like what kind of new systems can you get when you have localized systems?
That would be interesting in the city, and how does the money get issued? Does somebody have to, how does the conversion work back
I also think like UBI would also only like if you want centralized UBI like on like circles or something. I don't think UBI works at like a national scale because I just don't think people have enough empathy for people over large distances. But when you have like smaller communities, then you have enough like social cohesion to make, I think, UBI to be sustainable. That's just my personal theory. So I don't know. You can talk to Bucky about this. He has like a whole like you can look at his like Twitter threads about this, and like he has a whole bunch of stuff about talking about local currencies. And then I don't know. A lot of people shit on crypto fiat, but I actually think crypto fiat is completely okay and still optimal to current fiat because it might be centralized, but it still has transparency. And then you could have a system where like you don't like the government the government starts being corrupt, you can fork hard spoon the coin distribution. Like the biggest problem right now is how do we copy like the current distribution of wealth into a cryptocurrency if that's your goal. I don't know if it is, but if fiat was already a cryptocurrency, it's very simple to just copy it and now turn it into a decentralized distribution that's not controlled by a government. So I think crypto fiat's actually pretty interesting, and so I'm interested to see what like PBOC is doing with this. Yeah, finally done. So here's all our tools. Kind of walked through all of them, and I think I walked through how a combination of all these tools address all of these desires we have for Generation 3 blockchains. Cosmos to launch mainnet soon. So, now you know that this title is misleading because it's the Cosmos Hub mainnet, not the Cosmos mainnet, because Cosmos is not a blockchain. What we're launching here essentially is we're launching the Cosmos Hub, which is built with Tendermint and the Cosmos SDK and has our bonded proof of stake and Voyager support with What we do not have is IBC right now. Like I said, IBC is just in its spec and prototyping phase right now. And we figured, you know what, we're launching the first Tendermint chain with like valid proof of stake. Let's just make sure that works, and then we'll worry about IBC later. So but the SDK is ready to start developing on, and there are a number of teams already developing stuff on them. Keep in mind, it is an alpha. If you're developing on it, you have to be ready to you're going to be constantly pulling upstream code, and so that's just something you have to worry about. Keep in mind, and hopefully we should be pushing toward a 1.0 stable release of the SDK, hopefully within the next 6 months. And so that's what we're launching. And so you can learn more at all the links I've put throughout the entire slide deck, but also at tendermint.com and cosmos.network. Follow us at Twitter at Cosmos, or follow me at SunnyA97. Personal thing is I also run a podcast called Epicenter, so you can check that out. We do a weekly podcast on all sorts of things in the crypto space. I think it's the largest podcast in the space, so cool stuff. Cool.